We'll see in this tutorial how to process the dynamics of a wave with the Shaper Wave Dynamics software. The name Shaper Wave Dynamics is simply made up of the three main functions of this software, i.e. Shaper, like ShapeRoom, Wave, like WaveRoom, to make waves, and Dynamic, that's what we will say associates the wave at the board. To test the dynamics of a board, we will therefore need to do what is called a hydrodynamic scan of the board. This will also allow us to extract the dynamic properties of the board to make comparisons between two boards of board models for a given surfer. So we are going, here in this first tutorial on board dynamics, to learn how to scan the board. So here we are in a phase of the ShapeRoom, where we have just finished our board. We will say that I like this board, I will keep this board of this shape. Let's say she just finished shaping, here we have all her shapes. Well, it's a finished board. We are now going to scan it, and therefore we go to the Project tab, and at the level of the board, here we called it BlueTrick, we are going to see the last knot, at the bottom, which looks like a small pie chart with a graphics all marked. No hydroscan. So that means that this board does not have a hydroscan. It has not yet been analyzed in terms of its hydrodynamic performance. So that's what we're going to do now, we select the No Hydroscan node. This activates a tab at the bottom where we see the button, Hydrodynamic Scanner, Activate. Well, we will just click on this button and launch the hydrodynamic scan of the board. Here the user does not yet have a user number which allows him to sign his board, so we will fill in the user's information so that he can sign his blanks. So user setting opens the information panel, then we put the email address, so here we are going to put the user's address. Then this email address, for your information, it remains really secret if you do not click on Show my email address to the surfing community. This email address will remain secret. This information sheet will appear in the surf community, and if you want to communicate with other shapers or surf about the boards, and exchange ideas in terms of wave board, well, in fact this is what will appear in the surf community. We will see, or not, your email address if you have decided. Your name will appear and you select if you are simply a user who discovers the shape and hydrodynamics through this software, or if can be a professional who can send orders. That is to say that if you select this here, I sell and send the boards I share. In fact, the users will know that the boards that you propose and that you show in the surf community are for sale. Here you can put a link to your favorite websites. Here we are going to put FinSurf, here we go, we can test the link to see if it works. You can select a logo, so we have a small trail of logos, or upload one that matches your brand. The various infos, here you can put a message for the people who will wonder about your case. And so there, apply and close, and that will assign you a user number, so a connection that is made to the software server. And there you are registered, so you can sign your boards and possibly, it is just if you want, share them with the community. We can't save a board of the examples, to keep the basic models intact, so here I save a BlueTrick 2 copy. That's okay. And now I can go back here and do my scan. A small poster tells us that we may need to plan a little time. A scan takes between 20 and 30 minutes depending on the power of your computer. So I'm throwing it there. I'm going to explain a little bit what's going on. The software will go through a list of angles because in fact a surfboard doesn't go straight all the time. It quickly takes 5-10 degrees of side slip, and in fact the scan itself, it will calculate the hydrodynamic performance of your board. This is what is being done here, at all the different possible support points, which do not create any loading, nor tilting. nor stop the board because too far back, and it will save them. It does this for all angles from 0 to 90 degrees. Here what we can see on the right is the updating of the calculation of the various surfing positions on the board. And the hydrodynamic scan that we are carrying out here makes it possible to record the information of base in the board. And the calculation after a change of place on the board will be much faster, thanks to this scan. So it's a time of about 20 minutes of calculation, which will be largely recovered in our modeling in our tests in the wave. This method of hydrodynamic scanning is very particular because it makes it possible to record the balance of surfing on the board, and to determine the surface in friction with the water according to this balance there. This hydrodynamic scan is attached to the shape of the board. This is a rather important element, because it is not attached to the size of the board. That is to say that if the dynamic scan was made for a board of a given shape, like this one here, well, if we go after, in the length and volume tab, modify its length, we will not need to recalculate the hydrodynamic scan, because a hydrodynamic scan is valid for all board sizes. It is made for a given form, and if the form is not modified it will remain valid. This will therefore allow us to store another board in its library and modify its dimension to try. If we have a 50 kg or 40 kg surfer, we think that we will not have the same size of boards. So we will be able to modify his board and adjust the size of the board to the surfer in the wave, almost in real time. So it really is a tool for the shaper, depending on the weight of his surfer, and according to the size of his board, and according to the shape of the wave. He will really be able to offer surfers the board adapted to his needs, and his style of surf, and to the wave he surfs. The invention in this software is really what it is about. The hydrodynamic scan. It was really necessary to develop a very original calculation method to get rid of the finite elements, which are just unmanageable with the surf. That is to say, the finite elements is the calculation of drag in CFD on a given surface, at a given angle, at a given attitude with a given wave slope. And it is absolutely impossible to be able to understand what is happening on a board, if there is no movement on the board, if you are not able to modify the place of the surfer. It is also necessary to be able to include the volume of the board, for example during the take-off, to integrate the amount of thrust due to the hydrostatic, to the Archimedes effect. The hydrodynamic scan therefore makes it possible to separate the different elements that come into action during surfing. So here, we are going to let the dynamic scan do its job. It will scan the board, and we resume just after the end of this scan, so in about 20 minutes. So here is our board is scanned. So we know the hydrodynamic performance it produces when the surfer takes different positions on it. We recognize that a board has been hydroscanned, thanks to the small logo. It is a small percentage pie chart with a graph, which indicates therefore it has been analyzed. If we go to the library to see at the level of the boards, so at the level of the boards that are recorded, we will be able to quickly realize that a board has, or not, an hydroscan. In this case, the one we just did with it hydroscan, and we see in the project here that it has 11 hydroscans. That is to say the hydroscans from 0 to 90 degrees which are here. So we will now see how we can use these hydroscans. So here now I can enable dynamics. In the shape room, the dynamic option does not have exactly the same function as in the wave room, but we'll find the dynamic option both in the wave room and in the shape room. In the shape room, if you activate the dynamic option, you have the plan of the board and the positions that you can select on it. And when you select a position on this board that has been scanned, well, you can see the line of contact being updated at the different positions of the surfer. The line of contact is the line of contact with water, it is the area that comes into contact with water. Here still in the shape room, with the dynamic option active, and we can therefore scrutinize the performance according to a data which is here, i.e. the speed of the fluid, the slope, and the weight of the surfer. So here, there is no slope, it would be like toad surfing on a lake, and so at 5 meters per second. I can simply say to myself, well, what is the resistance drag of this surfboard at that speed? So I go to the dashboard tab, in the different elements here, and depending on my position on the board, I'll see that drag, friction, and shape have more or less important proportions. If I put myself on the back when braking, it's the form drag that will be especially important. You can see that the friction drag is low. If I go to the front of the board, we have more contact coverage, and then the friction drag will take over. We see the angles of incidence, planing angles. For example, here we have a planing angle which is 7 degrees. If I go to the rear, in the braking position, I have a 15-degree planing angle. So we can display here the different vectors that may interest us. For example, here I will show the radius of curvature. That's an important point. When we talk about the maneuverability of a board, we are talking about its ability to turn. So if I can turn easily, it's because the radius of curvature can be easily reduced. If I go to the side of the board, here you can see that my bend radius is reduced. If I go even further to the side, you can see that it shrinks even more. If I stay on the center, and well it lengthens, and we see here the radius of curvature, which is 61. So the bend radius versus stance is an indication of accuracy on the handling parameter of the board, because if when I'm moving sideways my bend radius isn't getting weaker quickly, that means my board is having trouble turning. So that's information that will allow us to compare very exactly between two boards and two surfers, what happens according to its position. So this will bring us to the dynamic parameters, and the analysis of a board in terms of dynamics. We will see in the Shaper report an object entirely drawn from this principle, which allows us to produce 3 dynamic ratios at 5, 20, and 40 km per hour, for this 80 kilograms surfer for example, and this board there. So we're just going to see what it looks like. We'll see in another tutorial how to properly analyze a hydrodynamic ratio, and how useful it is for the shaper to show his client the relevance of his choices. So here is the hydrodynamic ratio for this board, at the 3 speeds 5, 20, and 40 km per hour. We have a first graph here, which indicates the planing angles at the different positions. In the center here we see that we are going to have a minimum angle of attack of 8 degrees. And in the back here in the blue zone we are around 20 degrees. We see that the maximum angles of attack are to the sides in the tight cornering positions, and we reach around 45 degrees here. Like that, on its own, it is not necessarily very telling, but on the other hand, when we compare this sheet with the sheet of another board for the same surfer, this will strongly influence the choice, because we'll say, actually when I sit here, I still have a lot more angle of attack than with this board. We'll also see here, for example, the friction and drag, the part friction and planing drag on a board, following the different positions here. So always with a graph of the forces, in newtons, of friction, according to the positions of the surfer. And here a graph which in my opinion is very important, it is the maneuverability graph. Maneuverability, because it provides information on the radius of curvature according to the position on the board. We will reach very small radii of curvature when we are close to the rail, and very long radii of curvature when we are in the center, and that we are going in a practically straight line. The diagram below does not give the radius scale, and when we compare this handling graph with another board for the same surfer, we will clearly see the handling characteristic prevailing between the two boards for the surfer at such speed. Each wave having its own speed, we will be able to say to ourselves, for this type of wave, well, this board is really suitable for this surfer of this weight. We are really entering into a surfing argument that is based on real physical phenomena. We will now see how dynamics can be used in the wave room. Here we loaded a wave of 1 meter 20 in the wave room. And we are going to activate, therefore, the dynamics in the wave room. Since our board has been scanned and has its hydroscan, it can be used in the wave. If it didn't have a hydroscan, we wouldn't be able to fit it in the wave, because we don't know its hydrodynamic performances. So the one in our project, board BlueTrug 2, at 11 hydroscan, it can work in the wave, we just have to activate the dynamic option here. When we enter the wave room with a board, we will leave slow scrolling speeds. We will stay at 100th, because if we go too fast the software and the computer will not have time to recalculate the performance. And it will make a jerky trajectory that will have little interest in being analyzed. So we're going to stay at slow speed when we have the dynamic option in the wave. We see here that we can modify our attitude on the wave. We could, for example, display the trajectory here in the wave, and see how this trajectory varies with our position on the board. We also see that the position on the board influences the drag here. For example, if you stand back on the board, you can see that you will have a lot of drag. If we move forward, we have better planning, we see that the drag is decreasing. We will see how to quickly test a board in a wave thanks to the start options. Start setting. So you have to start by trying start setting. When we are on start setting, a poster at the top opens, and the wave comes to its beginning. The surf space is at its beginning. You can double-click on an area of the surf space to place the board where you want. And we will orient the board to the right or to the left, depending on the starting direction that we want to take. We are going to position ourselves on the board in one place or another to row, and to do our takeoff. We will also be able to modify the starting speed at the top. On this subject we will look at things, if the surfer is in a fairly rear position on his board, at the start here. We see that he has a strong angle of incidence, and we will look down here, in the performance. The power needed to move the board, at that speed in those conditions. If I accelerate, at the top, the initial speed, we see that the necessary power increases. Here we will have a power which is reserved. We will say to athletes, we see, there is a red line which says athletic power. And a blue line, we will say beginners or normal power rather. So we see here what we will be able to generate as an effort to go at such speed for our departure. We will see, for example, if I put myself further forward on the board, or further back, and indeed the power necessary at this speed is not the same. So we already understand very well here that it is in our interest to put ourselves as far forward as possible, at the limit of the loading, to row. We see that on this diagram there of the positioning of the surfer. If we put ourselves too far forward, we have a small poster that comes. It says that the surfer has been put back in his stability zone, because otherwise he would fall if he was further away. Here these areas are inactive. We cannot position surf in areas that are unstable, otherwise it would be unmanageable. So the software warns the user that here he has exceeded the limit of what is manageable. So we click, and if we have the small panel that appears here, hydrodynamics input surfer position out of stability area. It means that we have to get back into a more stable position. So here I'm going to put myself as far forward as possible, and I'm going to see that in this position, well, I'm going to be able to reach a speed, for a surfer of average power, of about 5.2 meters per second. In this small starting slope. I click on apply, and I will therefore simulate my departure in this wave. I can have fun accelerating a little bit, but we will see that we will have a limit. That's when it will start to jerk a little. So I can observe my departure here, and my performance. I could also show the performance history here, planing angle performance, and anything else that may interest us to analyze the board. You see it jerks a little, it is better that I slow down a little to be more precise. So here we missed the wave a bit. I'm going back to the start setting, I'm going to put myself in another position. A little higher, I'm going to go a little straighter in the wave, and I'm going to give myself a little more momentum. Like that, I'm going to wait for a little more the wave. Apply, and here we go, I accelerate a little bit for the start so that we can see what is happening, and so I have here on the left the moment of the takeoff, which will be displayed. This is when the board begins to have enough momentum to come down from the wave. Here the trajectory is up, the board is caught by the wave, and it gains altitude. And at some point, it will be able to go into planning, and there we will see that the takeoff is triggered. So we then slow down here, and we will also observe a small thing in the projections, here the flotation of the board, given the angle of the slope, has a component that propels us. That's really important for the start because it's really this buoyancy option, this buoyancy parameter here, which propels us to the takeoff, which will determine for a given surfer the volume of the board necessary for him to leave easily in a small wave or a big wave. Well, I'm not going to go much further on the performance in the waves in the dynamic option, because we're really going to dedicate tutorials for that. It's over here for this dynamics overview tutorial with Shaper Wave Dynamics.